All right, last lesson of Unit 10 is Lesson 10, Analyzing Graphs. Could be a kind of a fun deal here. On the back end, we're going to, we got a lot of work to do. But anyway, let's get after it here and finish up this deal so we're in good shape here. Data can be displayed. Displayed in various groups. All right, so let's take a look at this first histogram. Got a histogram. It says use the information to answer the questions below. Would you consider this data to be skewed or symmetrical? Absolutely symmetrical. You know, it's not perfect, but it's close enough. Would the mean or the median be the best measure of center? When the data is symmetrical, we use the mean. And when you use the mean, the best measure of variability is the MAD, the mean absolute deviation. So symmetrical, mean, and MAD. Remember, these two are linked. We talked about that in a previous lesson. Okay. Determine if the following statements are true or false. Okay, here we go. So looking at this, and let me pull this up just to make sure that you can see it okay. Yeah, you're good. All right, so what do we have here? First up is 19 students were measured and recorded. 19. Well, let's see here. You know, we've probably got 5. We've got 1, 2, 5, 6, 7, and this is probably 4. So 9, 10, 17, yes. So it is 19 total, so that is true. More than 90% of the class is 45 inches or taller. 45 or taller. So, all right, we have 18 out of 19, and that as a percent, I'm pretty sure is going to be higher than 90%, right? But let's check it. And it's 95%. So we'll call it a little more than that. So that is true. The mean of the data will fall between 50 and 54. 50 and 54. Well, when the data is symmetrical, we can assume that, yes, it will fall in between the middle. So that's why we use the mean here. Okay, so that is true as well. There are more students who are 45 to 49 than 55 to 60. No, that's false. Okay. Okay. And then we come down here, write 3 statements about the graph below. 2 that are true, 1 that is false. True. All right. Well, I would say the median would probably actually fall between 50 and 54. All right. What's another true statement? The data, all right, is symmetrical. The last one, the best measure of ability is the IQR. No, that's false. We want to use the MAD for variability here. Make sure you could see that. And I cut that short because of time. All right, let's continue on to the next page, number 4. Okay, let me pull that down a little bit. A survey of 15 households is conducted to determine the number of pets in each household. The dot plot below shows the data. All right, no problem there, right? So, would you consider this skewed or symmetrical? Well, you know, this is kind of a tough one. I don't think it's skewed left or right. I think it's almost, if we look at this, almost symmetrical. So it's not perfect, but symmetrical to me is the best answer. With the mean or the median? If it's symmetrical, we use the mean, remember that, and we use the MAD. the mean absolute deviation. What statistical question could be answered with this data? Okay. Remember, a statistical question has more than one answer, right? So, one, I guess, with the pets would be what? I guess, how many pets are owned by the households on my street? Right? So, how many pets are owned by the households on my street? So there's more than one answer to that, right? One has one has five, one has six, and so on. What's the most common number of pets? Most common number of pets here. All right, well, clearly that's what? Looks to be two pets, right? Find the mean number of pets. Round your answer. Okay, so we're going to have to add these up, right? So I'm going to grab my calculator, and I'm actually going to use my phone so I can see it a little better. All right, but I have a 1, I have 2, 4, 6, I have plus 8 for my 2s, plus 9 for my 3s, 8 for my 4s, 10 for my 5s, and 1, 6. So the sum is 42, right? And I'm going to take 42 and divide it by 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and divide that by 15. And when I do that, okay, I made a mistake, excuse me. 42 divided by 15 is 2 8/10, excuse me. Okay. All right, so now we're going to finish up with finding the mean absolute deviation, right? And to do this, we're going to have to do a little subtraction. And remember, we always take the positive value or the absolute value of this. So we already have the mean. The mean is 2.8, right? So now we're going to start subtracting from 2.8, all right? And this is going to take a little bit of work, but here we go. That's 2.8. That's 2.8. That's 1.8. 2 is 0.8. And we have a bunch of 2's, right? 0.8. This minus that is 0.8. 0.8. Now we're back to 3 minus 2.8 is 1.8. 1.8. 1.8. Now we're at the 4, so that's 2.8. And again, I'm just doing this mentally. And you should be able to bang through these. 5 minus is 3.8. 3.8. 6 is 4.8. So now, to find the mean absolute deviation, we add all of these up. Again, here we go. And when we add all of those up, okay, and I've already done this, we get a sum of 34. And we're going to divide that by the total number in the set here again, which is 15. We take 34 and we divide it by 15, and we end up with a repeating decimal of 2 26/100 with the 6 repeating. That's the mean that's the average distance each one of these numbers are from the mean. So hope that helped. Finish up lesson 10, and we're going to be finished.